Hi everyone, this is just a little bit of a review video. I'm going to start by reviewing the three different types of quadratic equations, or rather the three different forms that quadratic equations can take. So quadratics can take the form of standard form, which is ax squared plus bx plus c, where a, b, and c are constants and a cannot equal 0. Constants meaning that a, b, and c are numbers, right? They're not variables. And so in a standard form, we have a couple things that this tells us. One, c, the constant here, tells us the y-intercept. So it also can help us to determine how the graph is moving up and down on the y-axis. And a, which is our coefficient, and a is the coefficient for all forms, tells us whether the graph opens up or down and how skinny or wide it is, right? So whether it's vertically stretched, real skinny, or vertically compressed, open wide towards the x-axis. All right, so that's the first form, and this form is mostly used to help us find the y-intercept easily. The other form is factored form. And factored form looks like a times x minus r times x minus s, where r and s represent our x-intercepts. And so r comma 0 and s comma 0 are our x-intercepts. However, we have to solve for 0. So it's not quite that simple because sometimes there's that coefficient there. And so when we're looking at this, these equations help us to find the x-intercepts. Oh, I completely spelled it wrong. Intercepts, also known as our zeros. And so to do that, remember that we have to figure out when this would equal 0. So we can set that equal to 0 if, for example, we had, then we might recognize here that our two zeros are 2 and -3, because that's what would make each of these 0. And you can show that by saying x plus 2 equals 0. I can add 2 to both sides. I get x equals 2. Here, x plus 3 equals 0. So if I subtract 3 from both sides, I get x equals -3. So my two x-intercepts here would be 2, 0 and -3, 0. Now, once I have my x-intercepts too, my x-intercepts can help me to find the vertex, because the vertex is the midpoint between these two. So you can also use your x-intercepts to find the vertex, right? In this particular equation, we would have a x-intercept here and an x-intercept here. And so my vertex would be in between those. And to find that, we say -3 plus 2 divided by 2 gives us -1/2. So my vertex would be here. Let's go ahead and use a different color for that. Right? It's going to be along this line. Once I know that x value is -0.5, I can plug that into my equation for x and find out what the y value would be. Now I know that this equation is facing upward, right? So I'm going to assume that my vertex is down somewhere in this range here, right? That it would be somewhere down there. And that can help me to find out exactly what that is. So that's one with the factored. And then the last one is called vertex form. And vertex form, as its name indicates, tells us precisely what the vertex is by looking at h, k. And remember that our vertex is that turning point. It is either the maximum or the minimum of the graph. And this form helps us to immediately see what that vertex will be. And so when we graph that vertex, we can use that to start our graph So if we had a times x, actually let's assume that a is 1, x minus 2 squared plus 3, then our vertex here is 2, 3. And so once I have that, then I know that that is going to form my axis of symmetry along x equals 2. And so then, let's move this to the side here. I'm gonna take a look at that, right? If I graph this, then I have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 2, 3. My vertex is here. Now I know that I have a positive coefficient here with this equation, and so it's going to go up. I want to find another point to graph. So I'm going to try 0, and plugging in 0 gives me my y-intercept. So remember, with any of these equations, if I plug 0 for x, I get my y-intercept. That's a super important key point. Plugging 0 in for x gives us the y-intercept. Right? So in any form of the equation, we can find the y-intercept by plugging in 0. So if I plug in 0 here, I get 0 minus 2 squared plus 3. And so I get negative 2 squared plus 3. That's 4 plus 3 equals 7. So that means 1, 2, 3, 4, 5, 6, 7. That is where my y-intercept is. Now, since I know that, let me use this to make this as straight as possible here, that this is my axis of symmetry here, then I know that this point, which is 1, 2 away from the axis of symmetry, there will be another point 2 away over here, gives me a second point, and I can go ahead and graph that. Now, if I wanted a point in between, I can also plug in 1. You can plug in any number from the x-axis once you have the equation to see what you would get for y. So let's say I said, okay, I got my y-intercept, that's nice, but I want to see what other fact values I can get, right? So I said I plugged in 0, and I got 7. So now I'm going to plug in 1. If I do 1 minus 2 squared plus 3, I get 1 minus 2 is negative 1, but negative 1 squared is positive 1, because negative 1 times negative 1 is positive 1. 1 plus 3 equals 4, so 1, 4. 1, 1, 2, 3, 4. Okay? And then I know that on the opposite side, I'm going to have another point that matches that point. All right? And so when in doubt, I could plug in 3, right? We know that 2 is going to be 3, but I can plug in 3. And then what do you think I'm going to get? Well, I'm likely going to go ahead and also get a 4 there, because that's on the other side of that. 3 minus 2 is 1, 1 squared is 1, 1 plus 3 is 4. This will also be 4. If I plug in 4, what will I get? Well, I can see here that I'm going to get 7. Okay? So you can plug in x values and figure out the y values for the curve if you have the equation. All right, so that is your review of the 3 types of equations: standard, factored, and vertex form. Take a look and make sure that you know what the difference is in how they look, right? This has ax squared, the squared term is visible, plus bx plus c. Our factored form has it in parentheses and helps us to easily see our x-intercepts. And our vertex form has a parentheses with squared plus a constant outside of that gives us the y value for your vertex. All right, that hk is representative, h comma k is representative x comma y in your vertex. All right, now let's go ahead and push this to the side. I'm going to put that down there. And let's take a look at thinking about how we can get equations. All right, and what happens to our equations. So let's say we have an equation and we have a point here and a point here on our x-axis. All right, so let's say we have x. Oh, I didn't want to write x. I wanted to write what the number was. So this is negative 2, 0, we'll say. And then let's say this is 6, 0. Okay, I can start my equation by saying y equals a times x minus a negative 2 will be x plus 2, and then x minus 6. Remember that minus is part of the equation, so when I write x minus a negative 2, this becomes x plus 2. So now I've almost got my equation. The only thing I really don't know is my coefficient correct? So in order to know if my coefficient is correct, then I would need another point on the line. So if I was given that the y-intercept is 0, negative 4, I can figure out if there's a special value for a, if it's not 1. I know it's going to be positive because my graph is curving up. So I'm going to say y equals a times negative 4 plus 2 times oh, I did that backwards. I'm sorry. Excuse me. Just kidding. See, gotta be careful. Okay, I make mistakes. So this is x, this is y. So I need to write this as negative 4 equals a times 0 plus 2 is 2, 0 minus 6 is negative 6. These are all being multiplied. So I have negative 4 equals 2 times 6 is negative 12, so that's negative 12a. And now I want to get a all by itself, so I'm going to divide by negative 12. And then this will become positive, but a equals 1/3. It's going to be a fraction. And that makes sense because this graph does look a little bit wider, right? And so then I know that y equals 1/3 times x plus 2 times x minus 6. That's my new equation. I can rewrite that in standard form if I want to FOIL. Okay, so with that being said, let's review FOIL. All right, so FOIL is something what we say to mean that we are distributing and we're multiplying everything in the parentheses by everything in the parentheses. So with this, I can multiply the first terms, I can multiply my outer terms, I can multiply my inner terms. Remember, this negative is attached to that, so negative 2 times x is negative 2x, and I then multiply my last terms, the L in FOIL, which is negative 2 times 3, so negative 6. Once I've done that, I can combine my like terms. Remember, each one of these is a term. And like terms are the ones that have the same variable with the same exponent. So I can combine 3x and 2x to be just plus 1x, or just x minus 6. We can also solve this using the square, where we say x minus 2 times x plus 3. Again, the key and most important part here is that we keep that negative 2 there. Then we have x times x is x squared, negative 2 times x is negative 2x, 3 times x is 3x, and 3 times negative 2 is negative 6. Then I can again combine my like terms. We have x squared, 3x minus 2x is just 1x, and minus 6. So again, we get the same answer as we got here. The only difference is that I just used a different method of doing that. But this is how you take factored form and put it back into standard form to show that equivalency. All right. The next thing that I want to review is this idea that on the graph we have multiple points. My x-intercepts, or my zeros, are where y equals 0, right? On this point, y equals 0. It's not moving up or down off the x-axis, so y equals 0 there. And my y-intercept is where it crosses the y-axis here, right? It's that point right there where it crosses the y-axis, and that is where x equals 0. So y-intercept, where x equals 0, and crosses the graph. And then the last one is our vertex. And the vertex, remember, lies on the axis of symmetry. Here. Lies on the axis of symmetry, and it is the midpoint between your x-intercepts And so sometimes they're the same, sometimes they're not. In, for example, an equation such as x squared plus 6, here the y-intercept is plus 6. 1, 2, 3, 4, 5, 6. And also my vertex is going to be 0, 6. Because this is the same as x plus 0 squared plus 6. So if we're missing that middle term or the linear term, then that means this y-intercept is the same as the vertex. All right, let's take a look at this last thing that I want to make sure you are clear on. So our equations have many parts. When we're talking about this part right here, we're talking about this usually as the constant. That's the number that gives us our y-intercept. When we're talking about our x's, these are variables. This is called the squared term. This is called the linear term because notice it has a slope. It would form a line all by itself, so it's called the linear term. And then the squared term shows us that this is a quadratic, and then this number in front of that is called the coefficient. This 5 is also a coefficient, but the coefficient in front of x squared is what tells us whether the graph remains skinny, wide, the same, or whether it flips upside down. If we add a negative to this, it's going to flip upside down, we'll have a maximum. If there's a positive, it's right side up, open up with a minimum. Now another piece to that is if you just have x squared plus 5x plus 6, this right here has a positive coefficient because the number in front of x is 1. And so this would also open up because it has a positive coefficient of 1. All right, that's it for this review. If you have any questions, feel free to reach out, or if there's something else you want me to review, please let me know. Again, we have a test on Monday, so it's important that you feel ready. Oh, actually, I thought of one more thing I want to go over. All right, so the one other thing that I wanted to go over is how the graph shifts based on changes that we make, right? So if we have a graph that looks like this, right? And let's say our vertex is 1, -3, right? That looks about right. 1, 2, 3. It's very even, but you get the idea. All right, so let's say that our graph is this graph with vertex 1, -3, okay? Now, my equation then would be represented as x minus 1 squared minus 3, okay? I don't know why this is suddenly very small print. Let's try that again. Okay. And so this is my vertex here, right? That's our h, k. That's my vertex. And so if I wanted to move this equation to the left, I would go ahead and add something to this. Because if I add, let's say I add 2 in here. This now becomes x plus 1 squared minus 3, which would mean that my vertex is now -1, -3. And so -1, -3 would put that here, and then my graph would look like this. So I've now moved over 2 units, right? Because I added 2. Now, however, if I were to subtract 2 from the original equation, so let's make that x, instead of plus 2, I'm going to do minus 2, right? So now it's minus 3, x minus 3 squared minus 3. My new equation, or my new vertex is now positive 3, -3, which means that over here, 1, 2, 3, my new vertex is here, which means now I've moved to the right because I subtracted 2. So adding inside parentheses means it moves to the left, and subtracting inside the parentheses moves to the right. Okay? Now, when I want to talk about moving up and down, I'm talking about changing this part outside of that parentheses. And again, this is for when we're looking at vertex form, right? So if I'm changing this in vertex form, I'm changing this part here. Let me change my color to something we can see a little bit better. If I add 2 to this, and that makes this -1, then my vertex now is going to be at the -1, which means it's moving it up, right? If I were to subtract 2, it's going to move it down. So this is a little bit more predictable with those signs and a little less confusing. But again, if you're not sure, try doing it. If you add 2 to this, you're going to get this. That's going to move it this way. If you subtract, it's going to move it this way because we know that opposite sign, because the equation has a minus in it, that x plus 1 in parentheses, right, really means, sorry, the dog is crying. She wants me to feed her. It's a terrible sound. Is actually x minus a -1 squared minus 3, because this is part of the equation. This is the value of the vertex. Okay? All right, now I'm truly done. If you have any questions or you need help, again, please feel free to reach out to me, and I will be happy to support you over the weekend with studying.